this module, you'll acquire the toolset to build real-world user-facing applications, because there is more to Aleo than just the Aleo programming language. All users running the Aleo software, like they would do with the CLI, are called node of the network. So those nodes are prover, or they are validators, or simple clients. So they would just use SnarkOS and then start, and they would provide parameters. Here I'm missing my private key, but basically they would be running a node. So when people are running nodes, they appear. If you go to the Aleo scan Explorer, you go to nodes, and you will be able to see all the type of nodes that are connected to the network here for the testnet. So all those nodes, they automatically run a client so all those nodes they automatically run a HTTP server locally that you can request on the 3030 port. So basically, for instance, if I would be running a DevNet, I would locally be able to access that HTTP client using this address, then the port 3030, and then the network. For instance, on DevNet, this would be testnet. So I'm not running a node right now. We'll see about that later. So for now, let's just use the RPC API that is from the provable node that is maintained by Provable and exposed to the network by their team. So I could just access it for the testnet, for instance, using this path. So here the problem is I did not provide the full endpoint. So this is the base path for our RPC. But if I want to actually access one of the endpoints, the easiest would be to get the latest block height. And as you can see, it returns a HTTP response that includes just the latest height, which is an integer. So there are a lot of useful endpoints that you can use, especially for developing. All are not useful, but some are. Basically, the latest height could be useful for programs that have as an input a height. The hash, the latest block hash is not so useful for you. The latest block would enable you to get all the transactions within a block, as well as the latest header block. Latest state root is used by your SnarkOS tool to compute to get the latest state root, which is used to actually consume records. You would need that to prove the record you're consuming, prove the execution using records. And that endpoint for block would be to get a specific point at certain height. There is also the get blocks, which would be useful to get multiple blocks. The get height would be to get the height of a certain block hash. Get block transaction would be to get all the transaction within a block. This one can be useful. Get transaction is very useful, and you can get all the information about a transaction. Let's actually test this one. So we can here, so I will just paste here using the test network transaction, and this is actually HTTP GET, so I can do it directly from my browser. I take a transaction ID here. This is actually a deployment transaction. That would work. And here I got all the I got a JSON response with all the data from my transaction. So here, as you can see, there is a deployment of a program. All the code from that program is in the transaction, and this is how you get the content of any transaction. The mempool to get all the current transactions that are waiting in the mempool to be included in a block. The program to get the code for a specific program. Mapping name to get all the mapping names for a specific program. Mapping value for getting a specific value from a mapping. The get state path for a commitment is using a record commitment to get the state path associated with, so the Merkle path associated with that. The get peers count to get the number of peers connected to a specific node. All those around peers are not so useful for you. They are more for those running the network directly. Get node address, same here. Find block hash would be specifically to get the hash of the block for a given transaction here. Find transaction ID from program ID would be to get the deployment transaction, as you saw earlier, for a specific program that would return that, for that program here, that would return that transaction ID, for instance. Find transaction ID from transition ID is very useful when you have a transition ID. So as you know, there can be multiple transitions inside one transaction. With one of these transition ID, you can get back the full transaction. Find transition ID is to find the transition associated with an input ID. So the most useful endpoint is the transaction broadcast endpoint. And this endpoint, when you have computed an execution and proven it, you can broadcast the execution along with the proof to the transaction broadcast endpoint for it to be included in a block. So all those endpoints are pretty interesting, but sometimes you will want to have extra features that are not provided directly by the clients. So the first one you could use is actually the one provided by Aleo scan, one that is very useful. So this is actually already provided by a node, although listing all the mapping values for our program is actually not provided by a client, and this could be useful. Also keep in mind this could get really huge, in particular for the credits.Aleo program as well as the token registry. So be very careful with using those in your programs, as it doesn't necessarily scale as good as the request you would do to a client. So this is a very useful endpoint. You can also, the Aleo scan API also provide an API to simulate a transaction. So all the on-chain part would be simulated, and so you would know all the mapping updates associated with that execution. This is very useful for debugging your programs. So this is pretty interesting. Another community API I would recommend is the Leo RPC endpoint. So here you will have that inside of the course. It follows the JSON RPC specification, so it's different from the HTTP request you would do to a node. Let's, for instance, use it to get all the records in the ledger. And for instance, this is what is used inside of the Leo wallet to get all the records owned by the user. They just call that endpoint and try decrypting every record. That's why it takes so much time. So the way it can be used is by simply making a post request to one of the RPC endpoints. The endpoints are given here. You have the choice between testnet beta here for the current testnet, and mainnet as well. So it would be HTTPS mainnets .aleorpc.com to get for the mainnet endpoint. So there is only one endpoint for all those, one URL, sorry, for all those endpoints, and then you make a post request. That post request includes a body, and that body has params. So this is a whole body you would give it. And for instance, here there is a start and page. So you have everything that is documented here in this, in here. Some very useful endpoints. So what is really nice is that this API is totally free and it scales very well because the infra managed by Dmox Labs is pretty huge. And actually, you don't even need an API key. You can directly use it from the front end of your program exactly the same way they do it from their wallet. So I really advise you to use those endpoints. They're very practical. So this is it for the Node RPC and as well for the community driven APIs. So this is it for the client Node API as well as the community managed other APIs. You can look into what the community has built as well on GitHub directly, but for now this should be plenty enough. The second tool that we'll discover now is a tool to create an empty Aleo decentralized application frontend. So you have written your program, you have deployed it on-chain. Now, how do you make a frontend so users can interact with your application? So the first step to do that would be to use the npm create. So you would need to have npm installed. We covered that earlier in the setting up your environment module. Make sure you follow that. So create npm create Leo app at latest. It will require you to write a project name. I will leave it as default for now. Write anything you want. And then it will ask you to select a framework. So I think the React would be the best for creating a front end, considering that we'll need a package that depends on React later on for our front end. You could do it without React, but good luck with that, as you wish. So then we would select the React and TypeScript. You could also choose Next.js, any framework you want. And now, as you can see, it actually created our project. So if I execute the commands they recommend me here, I will run npm install, go to the directory, run npm install to install all the dependencies of the project. And then once this is done, I will simply run npm run dev. And so I can simply copy that address. And here we go. We have our Aleo plus React app. So as you can see, those are our React components. But what's interesting is that you can actually use functions, and those functions will be from the SDK that we'll see right after how it's built. And you will be able to include actually components in React that will allow you to interact directly with the Leo wallet. So as you can see here, we just run into the browser of the user. We just run a Leo program. And you can actually even deploy a program directly from the browser. So here there is an error with deployment because this program is deployed already. But as you can see, you can do anything that you would actually want to do from a front end using this app. So if we explore a bit how it's built, so it's really just a React, so index here just calls a main here that defines a React root, and this root actually imports our app. And our app right here has a few functions that are defined. Those functions actually execute functions that are depending on the Aleo SDK that we'll see later. So by just running this simple command, you have an app that is ready. And you can just start building on top of that. I think that would be the simplest way you would actually create a front end. So now that we have our project set up, we can begin using the SDK. So what is the SDK? It's a toolkit for developers to actually run from TypeScript or JavaScript programs, any Aleo features, run program, deploy them, be able to hash anything, be able to create accounts, basically anything you would want to do in order to build an app that interacts with an Aleo program will be available in that toolkit. So by default, when creating your app with Create Leo app, it will have, as you can see here, it will already import the SDK. So if you want to check how that actually works, you can go into your worker here. And so that worker actually relies a lot on the SDK. As you can see here, it's got multiple imports from that library. Okay, so let's say you're in any, so you can use that SDK both from Node.js on the backend or from the front end directly. So let's go into the content of the SDK directly from within our front end. So basically, the first thing we're gonna look into is how we can manage accounts. So accounts on Aleo are simply exported by the SDK. And if you want to create a new account, it's very simple. You just use the new keyword and you create a new instance of the account object. It will generate a random account. So I'll do everything here and click to execute. So if I want to actually log the account I executed here, I can go make console and we can see the account is here. So I can actually get the private key for that account and then I can represent it as a string. And now, here you go, we have our private key that is represented here. We can do the same and have our view key. And we can do the same and have, for instance, our address for the account. Okay, now let's actually use programs. So we can simply execute Aleo programs. Right here, let's do a local execution of our program. So our program is in Leo language. We compile it into Aleo instructions. Let's put those instructions here. Program. We'll just use a multi-line string like this. Okay, and let's see how we can actually, from the SDK, directly execute a program. So exactly the same way as you would do directly from your Leo, from Leo, we can just execute it. So how do we do that? Well, first I will create a program manager. My program manager was imported from the SDK. Then I will create my new account. I already, I removed it actually. Right here. And I will set that account for the program manager. So it will run the program when executing it. It will run it, but it will do so with the account that I put here. And I will actually call the run function right here. And I will need to provide that function the program instructions. Then the transition I want to call here is that transition here. And I will just give it two functions, two inputs. So this is the two U32 that are here. Okay, and now let's just log our execution. So our execution response actually will include multiple subparameters. So here it's all done inside the browser. So obviously it takes a lot more time to do that inside the browser than to do that directly using Rust. So this is because it is in WASM, so it was written in Rust, the SDK, but it was compiled into WASM to run into a web environment, which is way slower than running a binary on your computer directly. So I get my execution here, and I can actually get the outputs of that execution by using the getOutputs function. And here you will see that, oh, if I run that again, I should get the outputs for my function, which is a single output here. Okay, so now we know how to run locally programs, but we can actually run those execution on chain. So how can we do that? We will need what we call an Aleo client. So an Aleo client, Aleo network client we have here, is an object that will actually be able to interact with our client's HTTP client that we defined in the RPC module chapter 6.1. And we just create it by providing here network client, providing the RPC URL. And actually it will be very useful because we don't have to create all the HTTP calls. We actually need to provide a record provider, which is useful for managing the records associated with an account, and it will use a client to actually get those records. So actually the account will have, instead of creating a random account, we'll need the account that we have the private key to in order to have credits on here. Okay, and our private key. Here you go. Okay, get our private key here. And so when we run that, we'll have our private key object, which is just the private key here. Actually, our private key will define it as a string here. Okay, and so now we'll create what we call a program manager. So we saw that right earlier, and that time we are going to give our program manager everything we need here. So it's the same way as we did earlier for the local execution. It will use a key provider. This key provider just keeps tracks of the proving and verifying key of our programs. So we use cache true to let it know that it should remember all the key it generated priorly, so we don't generate twice the keys. And we actually provide a cache key here. And here we go. So we can now generate an execution, and we can actually get a transaction. So the first thing is here we generate our execution, and then we'll actually take our execution and publish it on chain using the network client, which we'll call the broadcast endpoint. So here is how we actually, using the SDK, create an execution to a function, and then we broadcast that. Let's just refresh. Program manager already been declared. We did it twice, of course. Program ID is not defined here, and it should be just that. Okay. Our function is simply supposed to be this. Hello. Okay. So we need to import that as well. And our fee is not defined. It should be simply, let's say, 1.6 Aleo credits. And our inputs should just be here. Let's say what we had before are this. So there is a lot to provide here, but once we're good, the key params here, simply that, wrong name, and okay, now it's creating the execution. The problem here is that it could not get the URL, and the reason for that is the program is not deployed on chain. But if the program were deployed on chain, we could actually generate that execution, and we would actually be able to broadcast that transaction to the network. So this is exactly how you actually do an execution that is then done on the network. Actually, for your programs, on your interfaces, you won't have to do that directly. All of that will be managed by the wallet itself using the wallet adapter. And if you have to use those SDK functions, most likely it will be in order to either create your own tooling and infrastructure, have more advanced use case, and so you should not, I'm showing this so you have an idea of everything you can do directly interacting with SDK, but it's most likely for your applications, you will not use those direct executions. So in the SDK, there are plenty more functions. A few ones. So here the init thread pool is to multi-thread those execution. So all your cores are used all your threads are used to actually generate those executions. You also have inside of the SDK all the credits functions that are already built in, so you don't need to redefine. So if you want to do a private transfer, a public transfer, you don't have to provide the Aleo credits here and do all that. You can just call a simple function from the SDK. Also, there is something you will use very often with this. It is the Aleo network client I talked about earlier. So most likely you will get a lot of mapping values. For instance, when you want to get the balance of a user in the Aleo in the credits.aleo program, you would just get the accounts mapping from that program at an address, and you would get the balance of a user. But a lot of the times you will need to actually not to get the key of the mapping you will call, you will need to either compute a commit or a hash of an Aleo object or of a struct. So the way you can do that is you cannot do that directly with the Aleo SDK for now, and that's very unfortunate, and it should come very soon. But because it is very, very important, in particular to compute, for instance, for the token registry, to compute values, that will be the token owner struct, for instance. You get a hash it, and then that's the only way to get the actual balance of a user for a certain token. Remember, the token struct, the token owner struct, is the account along with the token ID. You hash this, and then you know how much of that token ID, how much of that token with that token ID the token owner of the account owns by getting the value. It gives you back the balance, which has an amount. So if you want to actually do that, what you'll need to do is compute a hash. And to compute that hash, it is not provided directly by a provable SDK. So you will need to install this SDK, which was built by Demox Labs, the creator of Leo Wallet. And actually, you will be able to compute those hashes simply by importing here, for instance, the plain text here from the SDK. And then you would simply create a new plain text. So this is how this would be done. You would have here to provide a network. So if you're working with testnet, it would simply be testnet v0. If you're working with mainnet, mainnet v0. And then you would provide your struct. So if it's a token owner, here you would have the account with along with the address. You put here any address you want. And you would also have the token ID, which is a field, let's say 0 field. And so you would be able to compute the hash of the plain text by calling a specific function. I will detail all that in the course directly, but this is very useful. You can also compute commits for your token, for your NFT tokens, using the same SDK. So I really strongly advise you to look into this, as this will be provided in the written course. And I'll give the address as well. So this is a trick that not everybody is aware on the chain, and we hope that the Provable SDK will include those functions very soon. Okay, so now you know pretty much all the basics about the SDK. There is a last thing you should know, is that you can actually decrypt records, decrypt ciphertext directly using the SDK. For that, you should use the record ciphertext object that is exported, and you can actually create. So you create your account objects, and using your account objects here with along with your private key. So I get it here. You can simply provide the private key here. And then you can decrypt the record. So you give any record like this. And you would compute, so you can load the SDK object from the record. And you can decrypt it using the decrypt function. So you can check first if you're the owner, and if you're the owner, so there's a function for that, which is the following. So you check if this account is the owner, and if this account is the owner using the view key, you can decrypt it using the record view key. And actually you can, there's two functions for that. Either you use a decrypt function from the record ciphertext, or directly from the view key a decrypt record function. And that way you can decrypt records. Actually, you would never decrypt records yourself directly for your applications. This is for more advanced use case, because for decentralized application frontends, the wallet will decrypt for you. So it would decrypt every record there is on chain, and check if with your view key if it belongs to you by trying to decrypt it. And then for your applications, as we'll see in next course, in next chapter about the Aleo adapter, you would be able to actually get those records without any extra work. So everything I'm saying here about the SDK is mostly for very advanced use case, but it's very important to know that it exists. In my opinion, what you will use the most on the SDK is the Aleo network client, which enables you to interact with the client using JavaScript functions, and the account as well, to manage the account of users, and also the hash functions, sorry, and the commit functions from the Tmox Labs Aleo SDK. And now let's see what you would really use in practice using the Aleo wallet adapter. So now, using the Aleo SDK, we have all the tooling to actually access all the features of Aleo directly from JavaScript or TypeScript. So now that we have access to the So now that you know about the SDK, you have access to all the Aleo features directly from JavaScript and TypeScript, but actually most of those features, you would not use them yourself. The wallet does almost all the work in the background. For instance, the wallet has the responsibility to collect all the records that are owned by the user. The wallet also provides functions to execute transactions. And so in order to interact with those wallets, you don't have to have actually an integration for each wallet like Puzzle or Leo, but you simply integrate with a library that we call the adapter, and that adapter will then enable you to actually, as a developer, create a function that will be executed on chain that you can actually call directly using Leo Wallet adapter. So the adapter is kind of your Bible, and its role is really to give you flexibility on which wallet you can use, your user wants to use, and you just interact with that adapter. Okay, so the first step we have here is that we want to install the adapter. So the way we do that, we go into our project and we use npm install save this. I just need to add the legacy pure depths tag. Okay, and so in the meantime, we're gonna go to the documentation of our Leo Wallet adapter. So as you can see here, we can set up pretty easily that wallet adapter. So what we're gonna do here is that we're gonna import some packages. So let's go to our app here, and if we want to here, we'll just import this. So if we want here to use the wallet adapter, we're gonna use those tools we're importing. So using the useMemo hook, we'll store inside the wallets the Leo wallet adapter. So basically, those wallets, we would include several here if we had other wallets. We'll see about that right after. Then we would define the provider here, the wallet provider, and we would put that at the root of our application. So let's put it here. Actually, it autofilled this, and we'll close our application with that. Okay. So now it's using require. So let's get rid of that. And here. So now that we have that provider here, we can actually create a component. For instance, let's say we want to create a new button, and we'll ask for the user to select his wallet. So where is here our account button? Okay, let's just add a new button. So this is a bit messy. I will get rid of some of those. Let me actually get rid of almost all of that, but just a few buttons. And you'll see how easy it can be to create a button. So I will just create a new React component. So this will be just our wallet tests component. Let's put it here, and then we'll import it. Import wallet tests from this. And so now that we have that, we'll just export default wallet tests. And my wallet test will be just a simple React component. here. So within this, because it's inside the app, in here, I can simply use anything here that is exported. So it does not provide here something named default. This should work now. Okay. And so what we'll do first is we'll just create a simple button for users to connect their wallet. So just to explain a bit what happened here, we created a provider. Everything within that provider will actually be able to call the useWallet hook. And inside the useWallet hook, there are all kinds of functions that are provided. There is a public key of the users, everything. So let's try to use it. So let's import the useWallet hook. And it's exported from here. And as you can see, we'll be able to get the public key of our user by simply calling the useWallet hook here. The thing is, for now, it will be null. So actually, I got the wrong button here. I will use this one. And so this simple button will represent the wallet connect. So now you see it shows a model. And so there is a problem here. Some of the parameters that were provided are not the right one. So I guess those are the parameters that were provided to the provider here. Oh, so actually it's the network here, that it should be testnet beta. And now when we click here, you can see that it asks me to connect my wallet. So I will accept that. So for now, as you can see, we can only connect as a Aleo wallet. Here we cannot see our puzzle wallet, and we will see why a little down the road. But for now, let's just connect our Aleo wallet. Okay, so as you can see, my button here that I defined, my wallet multi button, will actually show my address, and it will show the icon of the wallet I connected. I can disconnect, and I can reconnect, change my wallet, and copy my address. So those are the base feature. Of course, you can, this library is open source. You can go and update that wallet multi button and actually be able to do it yourself. So you can display whatever you want. So what we will see now is everything that is in the use wallets here. Basically, this use wallets hook gives to you everything you need. So in this use wallets hook, you can get the address of the user. So here now, if I log that address, that public key, as you can see, my public key is displayed here. If I disconnect, it will be just null. So you have as a state your public key, but you also have plenty of other things. You can have all the records from the user, so you can just use the request record function. So you can actually use, in order to request all the records, so if request record is not null, let's just use our request record function, and we'll log the output. So actually, I think it's async, so we'll have to use another hook. So yeah, it's not defined here. Oh yeah, because I'm not using it in the hook. Okay. Here, request record is not a function. Okay, so what I will have to do is, I think I will need to use a useEffect hook because it's not defined yet from React, and I will just use request record as a dependency, and then I can just define that function here. And it will just call this async function, get records. And this get records is actually an async function. and it will only call that if it's not null. And here, that's why it was missing this. Okay. And what will happen here is that it will await request records here. And actually, we'll need to change to get the records. There are multiple, so you will need to read all the documentation for the wallet adapter. So every subpackage here is documented with all the permissions that are here. But basically, the idea is that when you have your application and when the user connects, it will require a certain authorization. Here we said that we would request every time we want to decrypt the record of the user, we need to request the user to do so. So it's pretty annoying, as you will see. So let's actually do it, and you'll see what we have here. Oh, actually, it's there now. Okay, so we have our request record function. Let's just call it here. Okay, select my wallet here. So get records here is invalid. Use effect. And I need to provide a program ID, let's say credits.aleo. Okay, let's refresh. And see here, it's asking me to share my record with the program. If I actually don't want every time I ask for the records to the program, I will need to change my permission here. But some users won't want certain permission. Here I get all the on-chain history. And as you can see, it will just ask me once when I connect. Here, my authorization to decrypt. And then here, I will have all the records that I can log. And if I refresh, you'll see that there is no record because I don't own any private credits, but they will all appear here. So there is no need for you to actually decrypt the records. Just using this function will give them to you. It's one of the most useful functions. So you can actually disconnect the user requests to make a transaction. So this one is very important as well. So the request transaction, you just use it. You provide here. So let's say we have another button. And that button here, and on click, we'll have make transaction. And let's define our make transaction function as an async function that will return, that will call that if it is defined. If it's not, it will return. Okay, and so it will just return a transaction ID, which is not the on-chain transaction ID, but which is a UUID internal to the wallet, in order to not leak any information about the history of the user. Okay, so we have our request transaction here, and we just provide everything we need. So in the requests transaction, it should be documented here, and our Aleo transaction is simply an object. So here, if I copy that, and that create transaction here comes from the wallet adapter base tooling that I told you about earlier. And here you go. So now here we just provide the public key of the user. We provide as well the network we want to do the transaction in. We have the name of the program, a transfer, let's say transfer public to public. Our input, which would simply be the address of the receiver, let's say a new account I'm creating. Okay, let's receive. So this and the amount. So the amount would be simply, let's say, I will send one credit. So 123, U64. And let's try it. So our Aleo transaction, and let's log our UUID. Once that's done, we actually got an error here. Our request transaction is not defined. Well, it was supposed to be here. Here, I accept. Okay, so now we got an extra button. Let's click on it. Sorry for the styling here. And actually, okay, let's do it here. So I'm connecting my first button, and when I click on that one, so I will just log some information to see if the button was actually clicked on. So it's the make transaction here. And I think this is because that's nil. So let's just log that to see if that's working. And yeah, no, it's a function, so we should be good here. Okay, nice debugging. And so actually no, it's nil. Oh, if it's equal nil, that I should return. Okay. Here our fee is not defined, so let's just define it as the amount of credit we want to give. Let's give 1 credit. It's way too high. Yeah, maybe just 0.1. Here. Okay, invalid parameters. So that must mean I reverse those. Actually not. This is my network, that's not the right one. And so I get that the parameters that are inverted now, they were right all from the beginning. And now there is no record fee because we want our fee to be private, so no, to be public. So fee public should be equal to 2. So this fee private should be false, because else we would have to provide a record as a fee. And here we go. Okay, so after a lot of debugging, we now have our transaction. And if I confirm here, it will be submitted to the network, and I actually get this back. Okay, so it's processing now. And I actually have, so maybe let's do some styling here. So button is here, and we'll put a little bit of text as well. Execute. Let's close it. Okay. Okay, power styling as well. Okay, so our transaction actually failed. Let's see why. On the Explorer. Oh, we cannot see it. Okay, I'll just look into my history since this is a public transaction. So on Aleo scan, maybe the reason it failed is I don't have enough in my public balance. No, that should not be the case. Here, and my recent transition is this fee. Actually, the fee here is nil, so I guess this is the reason. So I gotta provide the fee actually like this, not as. So the fee should be an integer. So this will be 1 Aleo fee, so 2.1, that's away. And now if I execute here, let's see, yeah, the fee is correct. And so, yeah, the last one failed, that's the reason. So now you see that it's processing, and so it should go on chain in a few seconds, and I'll be able to see that in the Explorer. Actually, I can, because this is a public transaction, I can see it directly here. So here it's a public fee that failed, yeah, because it was 0. So see, this Explorer is very useful because we have really anything we need in order to actually explore our transactions and debug what's wrong and what's not. And here it worked. And I can see it in the Explorer. See, the provable Explorer can be used as well, but I think it's less interesting to actually debug. It's more for general purpose. And yeah, here is our transaction on the network. So yeah, this is the first use case. I really advise you to go into the wallet adapter documentation. I'll put that directly in the course. That way you can access it. And in the next chapter, let's do our third assignment. Now that you get all the tools you need, you will be able to create your first front end for your private decentralized application. So we'll create an interface for minting your token that we defined in the last course, the last module. Your assignment 2, you add a token. Now, the first step will be to actually deploy that assignment 2 token, and then you will do all the interface. So you will be displaying the user balance for that token, and you will create a button that when you click on it, you're actually able to mint 10 tokens. So the first task you will have to do is deployment on the testnet beta network of your token. Then you will use the initialize function for that token in order to register the token on the registry. Then you will use the create Aleo app I showed earlier in order to create an empty Aleo app. And you will then update the app. So it includes one button that has mint 10 token on it. And when clicking it, it should actually call the mint transition from your previously deployed program. And it will use the Aleo wallet adapter for it. Then you will have a public balance for your token that you should display. So you should obtain that balance by using the authorized balance mapping. So in order to get the value from that mapping, you will need the key. So the key will be computed by computing the BHP 256 hash of the token owner struct. To compute that hash, you will use the Dmox Labs SDK. And then you will, once that hash is computed for the token ID and the token owner, you will get from the authorized balance the actual balance. You will need to divide it to get the right number of decimals, and then you can just show it to display it to the user. Then you will use the Aleo wallet adapter to get the records from the user, sum all the token records amounts, and from that token record amount, you can deduce the private balance for your user. So this is it, one button and 2 balance displayed, and you should be done with this assignment number 3. You now know how to make user interfaces for your programs. In next module, you'll learn how to actually test your programs.